Welcome to this web lecture about task-centered design. In this web lecture, we study through use cases and hierarchical task analysis how to describe the tasks that need to be supported by user interfaces. Typically, the analysis starts by describing some scenarios. They are informal stories of how the performance of a task goes. And because they are specific for a certain situation, they are personal and they are not generalizable. The first step towards generalizing them is to define use cases. They assume that you are interacting with the system, so they assume some understanding of the interaction with the system in order to perform the task. And then the next abstraction leads to essential use cases, where we abstract away from details like the specific order in which in a use case the actions are specified. We thus make not certain assumptions that are made in concrete use cases. Here is an example of a scenario for a shared calendar. You don't have to understand everything in the story, but it's about a user who wants to schedule an appointment with a group of other people. And so the story describes how exactly this is done with a calendar system and how the users, the participants in the meeting are described and how a date is chosen, how the choice is made between alternatives. And it's a very concrete, understandable story which doesn't really say what the interface should support. So from this scenario, we go to a use case, which is more concrete, and we see here an 11-step process, precisely what the user does with the system, from choosing the option to arrange a meeting down to the system having finished scheduling the meeting and writing it in everyone's agenda. There is choices to be made for which the interface offers options. The system will, for instance, check whether all the names of the participants the user wants, whether they are in the system. It will check whether there is a possible date. And it does everything in a very specific 11-step order. This allows us to ask some what-if questions. For instance, in step 4, there is a check whether the list of people is valid, but the use case doesn't say what happens when it's not. So we can now ask, what if the list is not valid? And then we go back to an earlier step. Or what if the system cannot find a potential date when everyone is available? Then the system will again have to show a message, return to an earlier step, and where you, for instance, can change the constraints for the meeting. Maybe a shorter meeting is possible. Essential use cases abstract away from the order as well. So there are now 2 columns in this figure. What does the user want to do? What is the system's responsibility? Here, for instance, we will see that the user will have to identify people attending the meeting and specify some constraints. The essential use case doesn't say that one needs to be done before the other. And the system will do both things, and essential use case, again, abstracts away from the specific order. This is one way in which we can describe tasks. Task descriptions are always used to envision how a new system could work based on investigating the situation that exists. A task that has been defined beforehand, how can we support that? We focus on essential aspects, like what exactly are people trying to achieve, and why is it necessary what they want to achieve, and how do they actually go about achieving it? Many techniques exist, and the most popular is the hierarchical task analysis, which we will study next. hierarchical task analysis breaks down a task into subtasks and each subtask into smaller subtasks. They are grouped to represent how tasks are actually done in practice. Right? So the focus is on physical, observable actions, things the users really do. But it includes looking at actions that are done with and without the software. You always start with a user goal and then sort of break it apart into steps that are needed to achieve that goal. An example of hierarchical task analysis is when you go to the library to borrow a book. Essentially, there are 4 steps. You go to the library, obviously, right? You have to there find the required book. Then you go to the shelf where it is, you retrieve it, and you go to the checkout counter, right, to register that you are borrowing this book. Each of these steps consists of a number of sub-steps. To find where the book is, there may be 5 sub-steps here that have to do with accessing the library catalog, right, and searching and finding where the book should be in the library. But finding the required book could also be done in a different way. So there are maybe different plans. If you borrowed this book before, then probably you know where it is. So you can execute what is here, plan 0. I do 1, 3, 4. I go to the library, I go to the shelf where the book is and retrieve it, and I go to the checkout counter. I'm completely skipping step number 2, but if the book isn't where I expect it, I will have to step back, go to the library system anyway, and do the search. A plan for step 2 can also be, I go to the system, I know what the book is, I just want to find the location. And so I know what the book is, I can enter the complete title, for instance. Right? If the book isn't identified, maybe I remembered the title wrong, right? I can start a search using some keywords. And so I have yet another part of the plan. An overall picture of such a hierarchical task analysis is shown on this slide. We recommend that for the tasks that you think we are going to do to test your final project, you make such an analysis and check whether your interface supports the interaction that is suggested and answers all the what-if questions that are possible in the description of this task, so that when we are checking out your final project, we don't end up having surprises. You need to foresee what we are going to do, have this description, which we are not asking you to put in your final report. Right? But you need to do it anyway in order to come up with a usable design. Thank you for participating.